talk about this A. A has 8 atomic numbers, so automatically it will be for A now. A will be 1s2, 2s2, 2p, to make up for 8, 2p4. So it will be 8. Now, the last electron is on the p orbital, so A can never be a s block element. So let's talk about B. The B is 11. So 1s2, 2s2, 2p, to make up for that 11, that will be 7, and that will be 6 rather, because the maximum number of electrons you can have for p orbital is 6. So the last electron goes to the what? 3s1. So definitely B is an s block element or a s block element. Then the C is 1s2, 2s2, 2p6, 3s2. So C is also a s block element because the last electron is on the s orbital. So in summary, it means that B and C are the s block elements. Chemical reactions. In a chemical reaction, we have reactants being used up and the product being formed in the process. Reactants, they are the species on the left-hand side in chemical reactions. They are always used up. Product, they are the species on the right-hand side in chemical reaction. They are always formed. Reaction time. What is reaction time? This is the time taken for reactants to be used up and product to be formed in chemical reactions. Reaction rates. This is the ratio of the change in concentration of reactant or product to the time taken for the change. Introduction to collision theory. Collision theory, it states that there must be collision between reactant particles for a chemical reaction to occur. Factors affecting rate of chemical reactions. 1. Nature of reactant. The reactant is a determinant of how fast or slow reactions are. However, some reaction may not even occur. 2. Concentration of reactants. The higher the concentration of reactants, the faster the rate of chemical reaction and vice versa. What that one simply means that a reaction that has a high concentration or a reactant that has a high concentration will take place faster, while those that have low concentration will be slower. Effect of surface area. The larger the surface area of contact of reactants, the faster the rate of reaction, vice versa. That is why a marble chips and a powder marble is a typical example to differentiate with respect to surface area. In a powdered marble, let's say A is a powdered marble and B is marble chips. The size of the marble chips is bigger than the size of the powder marble. So, and their component is calcium thiocarbonate 4. So in this situation, when this is bubbling to an acid and this is bubbling to an acid, this reaction will take place faster. It will be faster than this, simply because this powder marble will contribute a greater surface area to that solution or to that acid than marble chips. And that is the effect of surface area, which justify that the larger the surface area of contact of reactant, the faster the rate of reaction. And the slower or the smaller the surface area of contact of reactant, the slower will be the rate of reaction. Effect of temperature. The higher the temperature of reactant, the faster the rate of chemical reaction and vice versa. That means the reaction at high temperature will be faster than the reaction at low temperature. Effect of light. Some reactions are influenced by light. Example of such reaction is seen in a reaction of hydrogen and chlorine. It is negligible in absence of light. That means you don't notice it. It is passive in absence of light. But moderate in daylight. In daylight, the reaction is moderate. And in bright sunlight, it is very explosive, and such reactions are not carried out because of the fact that it is very explosive. 6. Effect of a catalyst. Addition of a catalyst tends to increase rate of chemical reaction. What is a catalyst? A catalyst is a substance which alters the rate of chemical reaction but itself remains unchanged at the end of the reaction. What it does basically is to enhance or to alter the rate of chemical reaction, and positive catalysts will promote the rate of reaction. It will promote it, while the negative catalyst will demote rate of reaction. Types of chemical reactions. We have exothermic reaction. It is one in which heat is liberated to the surroundings. The enthalpy of reaction is negative. Take note of that. In exothermic reaction, enthalpy is negative. In this situation, also, heat is liberated to the surrounding. In the endothermic reaction, it is one in which heat is absorbed from the surroundings. The enthalpy of reaction is positive. So you can use enthalpy to differentiate between exothermic reaction and endothermic reaction. In exothermic reaction, the enthalpy change, which is the heat content or heat of reaction, is negative, while in the endothermic reaction, heat content or heat change is positive. Chemical equilibrium. System in which there is no observable change in the properties of the system with respect to time. Example of such reaction is shown below. Sodium chloride in a solid state. You have a reversible reaction. Sodium chloride in a solid state. You have a reversible reaction, then sodium chloride in the aqueous state. So this reaction is said to be in equilibrium. Forward reaction is dissolution, while backward reaction is deposition. So forward reaction is dissolution. When you dissolve this in water, you have this sodium chloride aqueous. Then by deposition, that is by deposition, removal of water, then you have sodium chloride solid. And such a reaction is said to be at equilibrium because it can be reversed. This can go to this by dissolution, and this can go back to this by deposition. Effect of temperature. If the enthalpy is positive, the forward reaction is endothermic, while the backward reaction is exothermic, vice versa. Effect of pressure. Increase in volume favors the reaction part with lower number of moles, while decrease in pressure favors the reaction part with higher number of moles. Then effect of concentration. Increase in the concentration of reactant, the equilibrium position shifts to the right, thereby favoring the forward reaction, and vice versa. So questions. Rate of chemical reaction depends on the following factors, except A, rate at which gas is evolved, B, rate at which products are formed, C, rate at which color of reaction changes, D, rate at which the reactants diminish. 2. These are factors affecting chemical reaction, except A, surface area, B, catalyst, C, nature of reactant, D, activating complex. 3. What do we do to increase the surface area of reactant? Now, the rate of chemical reaction depends on the following factors, except A, rate at which gas is evolved. It does not depend. It does not, the chemical rate of chemical reaction does not depend on the rate at which gas is evolved. So it depends on the product that is formed. It depends on the color of the reaction changes. It also depends on the reactant diminish. But the one that is odd here is that the rate of chemical reaction depends on the following factors, except, so it's rate at which gas is being evolved. That's the answer A to question number 1. Question 2. These are factors affecting chemical reaction, except it has been enumerated in the previous lesson, those factors that affect chemical reaction. And one of them is surface area. That's A. A is not the answer. B, catalyst. Catalyst also affects the rate of chemical reaction because a positive catalyst will promote, it will speed up the rate of reaction, while a negative catalyst will slow down the rate of chemical reaction. So automatically, catalyst is also a factor that affects it. C, nature of reactant. Nature of reactants also affect it because if, like the case that I cited, powdered marble and marble chips. In the case of powdered marble, because the size is very small, so it will contribute a larger surface area to the reactant than marble chips, or it will contribute a larger surface area to the acid than the marble chips. So this reaction occurs faster. So also nature of reactant is also a factor that affects the rate of chemical reaction. The only one that is odd here is activating complex. Activating complex has no effect on the rate of what? Chemical reaction. So the answer to question number 2 is D. Number 3, what do we do to increase the surface area of reactant? If we want to increase the surface area of reactant, what we can do is simply to break it. To break it. So by the time we break it, we are trying to contribute, we are trying to increase the surface area so that it can react more, so as to fasten the rate or speed up the rate of such reaction. So the answer to question number 3 is A, that is breaking them into chips. Mass volume relationships. First and foremost, we talk about mole. The mole is the unit of measuring amount of matter